Welcome to the cold shop. Well, the pull came out pretty darn good. Here's a still picture of what the slice looks like. It's a little bit rough because it just came off the cold saw. And I think it's going to end up being a successful assembly. So, next step is I'm going to be cutting it into pieces and then assembling the chips using my Chipstack Assembly Kiln Rig thingy that I don't have a cool name for yet, but I'm still thinking about it. And anyway, I'm going to move the camera over and let's get to work. I'm going to be using my prototype wet saw to cut the piece into slices. My prototype has a fence, an adjustable fence for precision cutting, and it also has some drilled holes on the table to allow for the possibility of future, more complex work holding as I continue my quest for higher precision glasswork. Here's how the pull came out. Pretty uniform. It's not perfect. I always want to get it a little bit better, but it's actually, I think it'll be usable, and I think it'll be usable without reworking. Reworking is a very useful technique that I've used, especially with the squeezer, to resize and get the size perfect. But it involves another heat cycle, and from what I've read and heard, additional heat cycles aren't really that good of an idea, so I think I'm going to try to use it as is and just kind of like squeeze them into shape. Now the question always arises when doing this kind of work, how thick do I make them? Obviously, if I make them really, really thin, I get more usable pieces. But if I make them too thin, then they get a bit unworkable. There's nothing to grind away to get rid of surface imperfections. The thing becomes unusably thin, becomes much more difficult to work with just in general. So I'm going to aim for a 1/4 inch on my pieces, and I'm also using a thin kerf blade to try to minimize the amount of waste that I'm wasting in the kerf. And also, I don't know if you can see it on the camera here, but I put little markers, felt pen marker, Sharpie marker, on the pull, because I want to keep them aligned in order, in precise order as they come off the saw, which kind of helps a little bit when I'm going to be putting them together into the chip stack. It kind of helps a little bit, kind of like the technique of book matching in woodwork and veneer work, where adjacent slices will have a little bit better chance of lining up than slices further away in the pull. Now, of course, I know that the slice on this end and the slice on that end are going to be different, and once the pattern wraps around, well, I'm going to have to juggle some stuff and deal with some stuff the way it is. But hey, I start out this way and see how it goes. It's better to know where they are and know what sequence they're in than it is just to randomly throw them in. So, got the water going, blade on. When I'm cutting chips to do a roll-up, I typically cut them a lot thinner because thick roll-ups are a kind of a troublesome thing. They don't really work as well as one might think. When I'm doing sculptures, I actually like them thicker. It gives me more options for the way the things are going to be used, more options for mounting, and especially more wiggle room if I have a surface problem and need to maybe grind them away a little bit more to get below the irregular surface. My Chipstack method is pretty good at maintaining flatness and geometry, but it's not perfect. Nothing I do in glasswork is perfect. And so it's nice to be able to have that extra little bit of wiggle room. So periodically, it's a good idea to run the dressing stone the blade nice, and then also, even though I try as hard as I can to avoid chippage, sometimes I get a chip, and oh well. Just want to keep it away from the fence. Now, in order to make one of these patterns, I actually need 10 slices. And that is 1 for the center, and the vibration is starting to get me out of control here, so I may go ahead and move that. 1 for the center, 6 around the center, and then 3 that are cut into pieces to fill in the little weird spots around the outside, because 6 hexagons stacked together don't make a hexagon. But 10 hexagons with the outer ones cut into pieces make a very nice hexagon. So I got 1, 2, 3, 4, 5, 6. Now, of course, you may notice that what I'm doing here is very unlike what a lot of murrine makers do. A lot of murrine makers make a big piece, pull it into a small diameter cane, and get lots and lots and lots and lots of slices. I make a large complex piece, cut it into slices, don't pull it down really small, cut it into slices, and then make a very small number, sometimes only one final result. And yeah, it's a lot of work for one final result, but hey, I like it. Comes out cool. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is the preliminary cut. Now I need to switch. I made a little guide here. See if you can see that little guide. And this guide allows me to make the corner pieces, the little fill-in pieces. Let me get the chips off the table here and align. Gotta get fairly careful alignment here. One of the things I've been thinking about doing, another thing on my seemingly endless to-do list, is to try to figure out how to do precision cold working, possibly even to machine shop tolerance. Haven't done it yet, but seems like a fascinating idea that should be explored. So now I'm going to cut the little special pieces. And I think you can see how they fit in the guide. And then these little guys, find a nice looking orientation. And no, the patterns aren't perfect. They're probably the best I've ever made so far, but unfortunately they are not perfect. Of course, some people don't like perfect. Perfect looks robotic. Some people actually like the handmade look. So I'm a machinist, I'm an engineer. I always try for perfection, but hey, stuff comes out looking good anyway, even if it's imperfect. So now it's off to the Chipstack Assembly Fixture Kiln thingy. Okay, pieces have been cut to size and roughly assembled. I did a tiny little bit of further trimming after I turned the camera off, and it's probably not essential to show it, but you can probably guess what it was as I was kind of like adjusting everything to fit. I want to talk a little bit about the philosophy of what I did there, and that is that I've been taught by expert marine makers to minimize the number of heat cycles in a complex assembly. Many of my assemblies have been heated and cooled and heated and cooled and heated and cooled many times. And in the past, I've had problems when I took one of my designs and rolled it up and sleeved it with clear and then tried to make something out of it. Bubbles emerged aplenty. They were abundant, and of course that caused an enormous amount of trouble, often rendering the piece useless. And when I asked some of the people in the glassworking community, the best answer that I got was overworking the glass, that too many heat-cool cycles will degrade the glass, and as the glass breaks down chemically, it starts outgassing and emitting gas that forms bubbles. So I've actually been told that 3 heat-cool cycles is about the best you can, about the safest you can do. And of course, most of my stuff has more than 3, so I'm living in the danger zone. And so for this design, my pull was reasonably good. I mean, it's one of the best I've ever done, but I'm not a perfect puller. It wasn't perfectly pulled to size. When I measured it with a caliper, it was actually 20 thousandths of an inch smaller than my target size, which, you know, that's pretty darn good by eye with hot glass, but still, the pieces aren't perfect. They're not uniform. They don't line up in the pattern perfectly. If I would have put it back in the kiln, put a punty on it, reheated it, put it back in the squeezer, and resized using the squeezer, I would have got a lot more dimensional accuracy, and I have done this in the past. Many of my previous designs were resized on the squeezer, usually because my pulls weren't that good. And so on this one, I decided, hey, I'm just going to go with it. Just going to take what I got and see if I can squeeze it all together. So here's a close-up still photograph of the assembled pieces, showing that there's gaps and unevenness and the pattern doesn't line up perfectly, and you know, it is what it is, and I'm going to make the best of what I have by heating it, squeezing it together, and hopefully something will come out nice at the end. So I'm going to be moving back over here in the back of the hot shop, and This is my prototype experimental kiln rig chipstack thingy that I don't quite have a cool name for yet. I gotta come up with a good name. But at the moment, even though it doesn't have a good name, it's still really useful. And it consists of a Paragon caldera high temperature ceramic kiln called a high fire kiln that I've rigged up with a kind of a foot operated mechanism to raise it and lower it along a linear bearing. And then I've got my chips to be stacked are sitting on a special ceramic plate. And boy, it sure did take a lot of work to find the proper ceramic plate, because an awful lot of ceramic plates don't work properly in this application. And while I'm stacking, I'll be discussing a lot more about the ceramic plate. But for right now, the important part to see is that I made a little kind of a lifter kind of thing here with a little handle, and then the whole thing is mounted on linear bearings, and so I can slide it in, drop it down, remove the little forklifty dude, close the top, and then heat it. So I'm going to do that. I'm going to preheat and kind of soak in some heat, turn off the cameras, and then see if I can fuse them all together without destroying them in the process. So see you later. Okay, the kiln is at temperature. Looking back over here, and we are at 1500 degrees, which is reasonably close to the softening temperature of borosilicate glass. So I'm going to start the process of trying to stick these guys together using the Mirage hand torch with the same kind of a smallish flame, a smallish oxidizing flame that I used for striping and for most of the operations on this piece. I'm using a special paddle that I made. This has a reinforced top on it, so I can apply significant downward pressure to try to squish these guys down, squish them together to try to fill up some of the gaps that I have. Also going to be using a little bit of sideways pressure as well. The trouble with this operation, it's a kind of a delicate balance. I need to get the chips hot enough to stick and try to melt them together, but I also have a problem that they end up sticking to the ceramic substrate. And so it's a kind of a delicate balance that I've been trying to achieve here and now it actually has stuck a little bit. So I'm going to see if I can kind of like very gently get them unstuck. This is always a problem with this process. And of course I get them unstuck and they explode. I've been searching for a ceramic that has less of a problem with the pieces sticking, and haven't found it yet. This is definitely one of the problems with this technique. Usually I manage to figure out a balance. I am having a little bit more trouble today, but I'm cautiously optimistic that I'll be able to kind of get this thing to work. In fact, I'm having quite a lot more difficulty today. It kind of makes me wonder if different colors maybe stick more than others, or if it's just a bad luck day and I'm just having a bad day, but hopefully, maybe, with any luck, I will be able to get them unstuck. They usually end up loosening themselves as they cool down a little bit, which is kind of unfortunate because that means that I'm kind of losing heat a little bit. But hey, as I've said so many times in the past, it's all R&D. This is, as far as I know, I'm one of the very few using this technique. And even though I claim to have invented the rig, the technique itself is based on the pastorelli of old school furnace workers. So I'm hopeful, cautiously optimistic that I will be able to resolve this problem. Anybody who's seen any of my other videos knows that usually doesn't have this problem early on. I'm a tiny bit mystified. There we go. I suffered a little bit of disassembly, but I'm still very optimistic that I'm going to get a success here. This is the worst possible part of the process when I'm trying to get the initial tagging to turn it from a bunch of chips into a single piece that I can manipulate. But I think I may be past trouble time here, and on the road to success with any luck. I'm using, as I fumble around here, trying to get things back into some sort of arrangement, I'm using a special ceramic material. This is a high temperature alumina ceramic material that was actually quite a trick to find. For anybody who has not attempted to buy ceramic, the ceramic world, the industrial ceramic world, is very, very weird. When you do a Google search for high temperature ceramic material, you often come up with websites that say, contact our engineering team for a quote on your custom requirements. And of course, translated into English, that means you can't afford it. A lot of the advanced high temperature ceramics are very expensive. The places that they're used, laboratory equipment, semiconductor fabrication, highly specialized. And of course, the people that do that kind of work have lots of money, and cost is no problem. But for a glass worker, paying thousands of dollars for a piece of ceramic just makes no sense at all. So the first challenge when doing this is just finding a website with a shopping cart. Finding a website that actually has products for sale in stock. That's the first challenge. Then the second challenge is all ceramic is not the same, even if it's advertised using the same name. I found some material called pure alumina high temperature ceramic in a number of places. Found Chinese stuff on eBay. Found a very small number of industrial sources that have products in stock and prices listed on their website. Boy, this is substantially more troublesome than the last one I did. And of course, this leads to the observation of, wow, there are still many mysteries to be overcome, many problems to be solved in this, because I've never had this amount of difficulty with sticking, even when I'm being really careful. So, hey. So interesting world. Anyway, so I was saying that I found a number of products that all claimed to be high temperature ceramic based on alumina, and yet when I tried using them, they behaved very differently, and not necessarily in a good way. Some of them that didn't work very well were brittle and had just about no resistance to thermal shock. As soon as I hit them with the torch, they would explode. And I mean explode. I mean violently, throwing pieces across the bench. Then I tried some other stuff, and of course the ones that exploded, the way that I could tell that I was in trouble, after gaining experience, of course, the way that I could tell there was trouble is the pieces that exploded were all very shiny and really rigid, kind of like a floor tile or a dinner plate. And then I discovered some stuff that was sold by McMaster Carr, and they had it labeled as ultra machinable high temperature ceramic. And it was a soft material, soft enough to sand with sandpaper, that seemed to perform a little bit better. Unfortunately, as anyone who has ever dealt with McMaster Carr knows, they are not the low-cost supplier. They have an excellent website, excellent customer service, excellent delivery, and high prices. So, fortunately, when the package arrived, it arrived in packaging that actually had the manufacturer's name on it, which was Zycar Refractory Ceramic. So I contacted them directly and discovered that they had a material that they claimed was specifically designed for glasswork. And that's what I'm using now. It's a softish material, which is soft enough to scratch with a fingernail, soft enough to sand with sandpaper, and seems to work really well. But as you can see by the trouble I'm having, it still sticks to hot boro. And I have not found an answer. Still looking for an answer. My answer right now is just to kind of finesse it and just operate right on the hairy edge of sticking, periodically kind of bumping the piece around and just seeing if it's sticking, seeing if it's still loose. I've tried a variety of different materials. I tried kiln wash. I tried the typical material that is recommended to coat kiln shelves with, and that comes in multiple different varieties. The Paragon material is very coarse and sand-like, and it doesn't really prevent sticking. It maybe reduces sticking a little bit, maybe helps a bit, but the bad news is it's really coarse and sandy, and the sand comes off and gets stuck in my work. Sometimes, if I'm lucky, I can cold work it out, but sometimes it gets embedded really deeply and kind of ruins the piece. Then I tried Bullseye Shelf Primer, which is a finer grade of material that has less kind of a sandy, it's more like fine powder than coarse sand, and it works a little better, but it's not perfect. I haven't yet found a material that totally eliminates the sticking problem. So the adventure continues, the R&D continues. If anybody out there in YouTube land knows the answer, please educate me. I would love to have some expert guidance, but at least as far as I know, the people who have taught me to do chip stacking, and all of the chip stacking that I've seen, either live or on YouTube, has been done basically in thin air, with the piece on a punty. And I've just never been able to achieve much success with that method. I far prefer the precision of cold assembly and being able to fuse things together after cold assembly. So, as far as I know, I may be the only one that does it this way. But like I said, if you're somebody out there in YouTube land who's doing it this way and you have mastered the technique and know all the secrets, I am open to education for anyone who wants to share. So, getting far more stickage than I've ever gotten before, and I don't know exactly why. I don't know if my ceramic surface has changed, if it's degraded, if this particular color of glass is a problem, but I believe that I have overcome my difficulties. And I believe that I have accomplished a successful fusing So now I'm switching to a very small, gentle flame to fill in. There's a couple of little voids, little areas where the inaccuracy of the pattern resulted in a little open spot that I've been trying to kind of gently coerce the open spots together and fill the holes. And by using the very, very small flame, I'm able to very carefully, without overheating, kind of address those few little open spots that haven't been pushed together. And of course, like everything else, this is a balance. I'm trying to distort the pattern as little as I can as I stick it together. And then of course, while I'm sticking it together, I'm also trying to keep it loose on the pastorelli. And I believe that after a rather challenging start, where I was seriously concerned about failure, that I may have actually achieved something kind of close to success here. Of course, as I'm doing this, I'm reviewing my thought process and wondering, would I have been better off if I had resized, done a hot resize on the squeezer? So that is, I think I've pretty much filled up all the holes. The surface looks smooth. It all looks fully melted in and bonded together. I'm going to give it another couple of flattening squeezes. But everything about this process is always a trade-off. It's always a question. Every time you get one thing, you give up another thing. So, like so many things in glassworking and so many things in life, it's all about balance. I'm very, very careful and very, very aware, watching the surface to make sure that I'm not degrading or boiling or bubbling or in any other way destroying my surface. I'm also, as I use my paddle, there's always a chance I can catch an edge and make a divot. Also, I'm trying to do strictly downward pressure because sideways sliding is often a really bad deal. Sometimes I can smear my pattern using a sideways sliding motion. I learned that very early on in the exploration of this process. So that does it for that side. I'm gonna flip it. Flip it good. And then back in for the second side, which hopefully will be ever so slightly less annoying. So, I'm gonna turn off the camera, wait for the kiln to come back to temperature. Unfortunately, the little Paragon caldera is extremely underpowered, and putting that cold piece back in just drops the heat like a rock, and so it takes a while to recover. So, be back in a few minutes. Okay, we're back up to working temperature. Can do the second side now. The second side usually is a lot easier and goes a lot faster, and hopefully Yeah, it's really loose. I won't have the same kinds of problems because it's almost completely bonded together. And I thought I'd probably take a moment or two to talk about philosophy again. Yes, I am a wannabe philosopher, and yes, I do spend too much time talking about philosophy, but hey, somebody has to. Why do I show videos where I'm having trouble? Why don't I just cherry pick the stuff where I do perfect work and never show my mistakes? Well, first of all, I don't do perfect work. Even my best isn't perfect. And second of all, for people who are thinking about doing this kind of work, it's kind of important to know that things don't always go right. And one of the pearls of wisdom that I've seen over and over again, people saying it's not what you can make, it's what you can save. So, also, this tech is new. Nobody taught me to do this. I don't have a master teaching me how to do this. This is an inventor using the machine for the first time. Kind of reminds me a little bit of the story of the inventor of the helicopter, Igor Sikorsky. Not only did he invent the helicopter, but he taught himself how to fly it. And for anybody that's ever tried to learn how to fly a helicopter, gadzooks, that must have been hard. Even with an instructor in a modern helicopter, hard to learn to fly. And yes, I have tried. I have taken helicopter lessons, and they are not easy to fly, I tell you. And then you imagine that the inventor taught himself to fly in his first horrid prototype that barely worked at all. Wow. Anyway, I just show my work. Good, bad, otherwise. And hopefully I demonstrate recovery from difficult situations. Well, if it's a truly catastrophic failure, a crash and burn failure, I'd probably delete the video, but in most cases, I just show the work I do. And for all you who are out there thinking about learning glasswork, even the experts have problems. I've seen top experts have pieces crack, fall off the punty, things not turn out the way they expected. It's a very difficult art form. Anyway, another theory that I have is that this plate, the ceramic plate that I'm using, may be nearing the end of its useful life. These things don't last forever, and I may have some sort of degradation. Or just yet another mystery to solve. Inventing is all about solving problems, discovering what went wrong, troubleshooting. Now you might wonder, some might wonder maybe, why am I not doing it on graphite? Well, graphite burns. If I could do it in a vacuum, I would love to do it on graphite. But with the direct torch flame like this on graphite, yes, when I first started, I tried doing it on graphite, and had some success. It wasn't a complete failure, but from what I've read in scientific work, not scientific glass blowing, but other types of material science, graphite crucibles in a non-oxygen atmosphere, in an inert atmosphere, can be used up to 3,000 degrees F. Or actually, no, 3,000 degrees C, I think, if I remember right. Anyway, super, super hot. Really, really hot. Hotter than I would need to do glass work. But unfortunately, I can't work in an inert atmosphere. I suppose if I was crazy, I could build a sealed room and fill it with argon and wear a spacesuit, but, I'm not that crazy. Anyway, the challenge in this process is to try to come up with a substrate that doesn't stick. If I had a substrate that was absolutely impervious to sticking, I'd be a lot happier. Now, boy, this is the worst sticking I've ever had. I think I may investigate swapping out to a new plate. These plates don't last forever. They do degrade with use. I've read that boron nitride might be a really, really good substrate. High temperature, good thermal shock resistance. But once again, when I went to buy it, I think I got a quote from some scientific company that offered to make them for like $1,000 a piece. And I don't think that one's going to be for me. I did see a few on eBay from China for reasonable prices, but they were tiny. I mean tiny. I couldn't even get my piece on the tiny ones they're selling. So I'm thinking I'm gonna call that guy ready to go. Now, I've over here on the NQALHA been preparing a little moil punty guy, because the next step, I'm going to refine it on the squeezer, and in order to pick it up, I have to have something to pick it up with. Now, I got to be really, really, really careful when I do this, because once I pick this guy up, it is a kind of a precarious geometry. So I do have to kind of be careful, but hopefully I'll be able to keep it under control. So out comes the punty. I've already got the squeezing dies in place. And while I think of it, let me turn on the squeezer cam. I can't show the squeezer without the squeezer cam. So take the piece out, make sure that it's still loose. got to be really, really careful when putting a puntee on a thin piece like this, because it's like super, super, super easy to distort my piece. And there we have it. Being very careful to not drop the clamp on the NQALHA, because that would shock it but good. So now, I'm gonna make sure that I've got a nice, happy piece. It's a little off center. So one thing that I need to do, the edges of this piece, I was unable to bond them fully together to totally melt them in, because kind of impossible to do. You can't really get the edges hot enough because the edges are kind of like laying on the substrate, and it's soaking out all the heat. So I'm gonna try to see if I can get this guy hot enough on its edges to perfect my hexagonal geometry. And it looks like I selected the wrong size squeezing dies. So let's get Mr. Bunsen out here as I go back. That's one of the downsides of the fixed size dies, that even though I'm trying to make this to a dimension, I actually have a CAD drawing that shows the dimensions I'm shooting for. You know, my technique is not precise. Sometimes I miss a bit. And the good news is the quick disconnect squeezer dies make it fast. I wouldn't want to have to be getting out the tools and unscrewing stuff at this point. That wouldn't be very good. So let's get Mr. Bunsen out of the picture. Keeping the piece this thin from warping is a challenge indeed, I tell you. But I have succeeded at this process before, so I know it's not hopeless. It's just difficult. Well, there, I believe I actually have some reasonable progress in fixing up that outside edge. Got a few little trouble spots here and there. I get a very, very small flame here. Kind of a gentle oxidizing flame. In fact, maybe yeah. Still learning. Still trying to figure it out. Just trying to get a nice uniform amount of heat on the piece. I believe that I have got, it's been hexagonated, but it also kind of drooped a little bit, so I'm going to try to flatten him out a little, but I believe that I am on my way to success here. Probably just a little bit more heating. And no, I'm not going to try to remove that punty in the hot shop. That guy comes off with the cold saw. Getting smoother. The little cuppiness that I had before seems to be gone. Very, very, very close now to calling it done. Giving it one more little bit of paddle with gravity assist. It's another reason that, yeah, I don't know if I like that. Pretty straight. That's another reason that needs just a bit more. That's another reason that I make them a little bit thick, because along the way, it's hard to keep them perfect, and if I need to grind away material to flatten it, it's nice to have material available to grind away. Okay, I'm thinking one more time. No. I think I'm going to stop dicking with it. Going to call it macaroni. I think if I keep dicking with it, it ain't going to get any better. So it is what it is. I'm optimistic it will actually come out pretty nice. But yeah, there's the result. And I'm not going to put it in the kiln too hot. Going to give it a little bit of a chance. I don't want to distort it when I put it in the kiln. I'm kind of carefully finessing. In the kiln it goes. And that will do it for today's glasswork. Thank you for watching. It's been fun, and a little annoying, and a little challenging, and well, right on the edge of failure at times, but I think I pulled it off. I think it's actually going to work. We'll see you next time in cold working. Bye-bye.